In the last video, we looked at expanding things like cos 5 times A and sine 7 times A in powers of cosine A and sine A. In this video, we're going to go the other way. We're going to start with a power of cosine, say cos to the power 5, or a power of sine, sine to the power 7, and see how we can expand them in terms of cos 1A, cos 2A, cos 3A, or perhaps sine 1A, sine 2A, sine 3A, etc. Before we can do that, we have to look at one or two preliminary results. We know, or we should know, that z, which is e to the I theta, is cos theta plus I sine theta. 1 over z, therefore, is e to the minus I theta. That's cos of minus theta, which is the same as cos theta, plus I sine of minus theta, which is the same as minus I sine theta. Well, if I add those two, I get z plus 1 over z is equal to cos theta plus cos theta is 2 cos theta, and the I sine theta disappears. If I subtract, I get z minus 1 over z, and the cos theta disappears. Minus minus is plus, gives me 2I sine theta. These results also work if we're dealing with z to the n. And this gives us the same equations, but with an n in. Z to the n plus 1 over z to the n is 2 cos n theta, and z to the n minus 1 over z to the n is 2I sine n theta. We will need to be able to think either there or there. The left-hand one, of course, is just a special case of the right-hand one. Right, let's look at an example. Express cos to the power 5 theta in terms of sine theta, sine 2 theta, sine 3 theta, etc. Well, I've put down here the little equations that we have just proved. We want cos to the power 5. So we start with this equation, and we raise it to the power 5. So I start with 2 cos theta equals z plus 1 over z, all to the power 5 on both sides. That tells me that 32 cos to the power 5 theta. Pascal's triangle now, 1, 5, 10, 10, 5, 1. Z to the 5 plus 5 z to the 4, 1 over z, plus 10, I don't want the bracket yet, z cubed, 1 over z squared, plus 10 z squared, 1 over z cubed, plus 5z, 1 over z to the 4, plus 1 over z to the 5. That should be fairly easy for you. You should be good at the binomial. Notice z to the 5 plus 1 over z to the 5. I like it. Z to the 5 plus 1 over z to the 5 is 2 cos 5 theta. I like that. So let's write this now as z to the 5 plus 1 over z to the 5. What happens when we look at the next term? We get 5 times z cubed. Moving up here, 5z over z to the 4 is 5 over z cubed. 5z cubed, 5 over z cubed. That is going to be 5 times z cubed plus 1 over z cubed. And I like that one. And let's look at the 10 now. First of all, with the 10, we have z cubed over z squared, which is z. Then we've got z squared over z cubed, which is 1 over z. z plus 1 over z. So now this one is 2 cos 5 theta. This one is 2 cos 3 theta. And this one is 2 cos 1 theta, or you've got it there. Two times 5 is 10. And 2 times 10 is 20. All we have to do now is divide by 32, and we get cos to the power 5 theta is equal to 2 over 32 is 1 over 16 cos 5 theta. 10 over 32 is 5 over 16 cos 3 theta. And 20 over 32 is 5 over 8 cos theta. There we are. I think the main use of this is going to be scoring a few marks in your exam. It's not something I've ever used in earnest, but it's quite a nice little answer. Nice little technique, and not difficult to do. You must first remember or work out these little equations at the top, and then all you have to do is spot that cos to the 5, I need to raise that one to the power 5. Another example coming up. Okay. Express sine to the 4 in terms of cos 1 theta, cos 2 theta, cos 3 theta. Same sort of idea. I've written down the equations for you. We want sine to the 4. That's no use. This one works. So we write down this equation, 2i sine theta equals z minus 1 over z, and we raise everything to the power 4. Two to the 4, 16. I to the 4 plus 1, sine to the power 4 theta. Z to the 4, 1, 4, 6, 4, 1, plus 4 z cubed, that's supposed to be a 3, minus 1 over z, plus 6 z squared, minus 1 over z squared, plus 4 z minus 1 over z cubed, plus minus 1 over z to the 4. Well, we know what we're looking for. We're trying to pair things up. Z to the 4 minus to the 4, that's plus 1 over z to the 4. Z to the 4 plus 1 over z to the 4. And now I'm going to have 4. I've got 4 z cubed minus 1 over z. That's minus 4z squared. And here I've got minus 4 over z squared. So that's minus 4z squared minus 4 over z squared. Oh, I like that. And in the middle, we've got 6z squared over z squared, and it's positive. So that's plus 6. This is going to be z to the 4 plus 1 over z to the 4 is going to be 2 cos 4 theta. This is going to be 2 cos 2 theta, so let's just put those in. 2 cos 4 theta minus 4 times 2, 8 cos 2 theta plus 6. Divide both sides by 16. 1 over 8. Let's make that a better 8. 1 over 8 cos 4 theta minus 1 over 2 cos 2 theta plus 3 over 8. There is a slight difference when we're dealing with sine to an odd power. Just to keep life easy, we'll just look at sine cubed theta. Express sine cubed theta in terms of sine theta and sine 3 theta. Well, I want sine cubed theta. I'm going to be using this one. So I write down 2i sine theta equals z minus 1 over z, and then we cube both sides. This side is going to be 8. I cubed is minus I sine cubed theta. The other side, Pascal's triangle, 1, 3, 3, 1, z cubed plus 3 z squared minus 1 over z plus 3z minus 1 over z squared plus minus 1 over z cubed. The odd power with sine will always have an I here. No problem, just carry on, follow your nose, and everything drops out. We've got z cubed minus 1 over z cubed. I will do the next one just a little bit more slowly. This is minus 3z and the next one is minus squared is plus z over z squared plus 3 over z. Which is now z cubed minus 1 over z cubed minus 3 times z minus 1 over z. That works, yes. Now, what am I going to do? I'm going to use this fellow. Z cubed minus 1 over z cubed is 2i sine 3 theta. So this is 2i sine 3 theta minus, and z minus 1 over z is 2i sine theta, 6i sine theta. I said don't worry about the I. When we divide both sides by minus 8i, the I disappears with no problems at all. So dividing both sides by minus 8i, I get sine cubed theta is equal to minus 1 over 4 sine 3 theta plus 3 over 4 sine theta. So these really are just a case of remembering the first line and then a bit of simple algebra. But you must recognize the difference. Sine cubed, sine to the 5, cos to the 6, cos to the power. Whenever you're dealing with a power, you must start with z plus 1 over z, z minus 1 over z. What we did in the last video so earlier we found cos 5 theta as powers of theta, well, cos theta or sine theta, using cos 5 theta plus I sine 5 theta, don't really need the brackets, is cos theta plus I sine theta to the power 5. It is a different technique. Cos 5 theta, cos 6 theta, sine 7 theta, sine 3 theta, you must start here. Cos to the power 5 theta, sine to the power 3 theta, sine to the power 7 theta, you must start here.